I carefully trimmed and taped all the enlarged pages together, so now I just have one big wiring diagram, easier to work on, and it's helped me solve a little puzzle I've been wondering about, which is, what is that thing between the filter choke and the speaker field? It looks like some sort of interlock, I figured. It's not the fuse, it's not the power switch. So what is it? Well, let's trace out the wiring and see what goes to that end of the filter choke, which is up here. So if we trace one end, goes around and around and around over to the rectifier tube, and the other end goes over and over and over and over up into the 1.3 microfarad cap that's inside this box. Okay, well, what about the other end? Well, it goes over and around to this terminal block. So I thought maybe that's what they mean, but must go to something else besides just that. So if we trace it down, it goes unfortunately into this, which is just that bus. But if we look close, check out what that little symbol there is, and trace around that wiring bundle, it seems to me it's this guy right here. And the other end, after that interlock, is supposed to go to 16 microfarad cap, speaker field, optionally a 4 microfarad cap for 24 hertz power versions, and to the center tap on that output transformer. Well, here's the output transformer, here's the center tap, so it's going over to here. So what is on that actual speaker connector between those two? Well, if we look, it got just a short. So the idea is, if the speaker is not connected to the chassis, you don't get any power. There's no B plus going to the set. Power stops right there. And it'll energize that cap, but that's it. So if you were to plug it in and go poking around, you could get a little shock from that charge that capacitor is going to hold, but the rest of it will be dead. Speaking of the speaker, I'm starting to do a little bit of work on it, picking off some of the old residue around the frame. And I went over to Joann Fabrics and picked up an embroidery hoop. This will allow me to place a piece of fabric on the inner hoop, stretch it, and keep it held, stretched and taut with the outer hoop, and tighten this down. And then once I finish cleaning this off and lay down a bead of glue, I can lay this down. I realize these mounting brackets stick up a little bit proud, but not too bad. I don't think that'll really be too much of an issue. And I got so lucky in that this just fits around. Pure coincidence or pure luck. And as for this edge, I thought that under the crud it would just be the metal frame, but no, there's actually like 1/8 of an inch of, I don't know, hard felt or cardboard or something. And the leather appears to have been glued onto that. And actually, I think there's something missing. Because if there's anything, my other speakers I've seen like this, they had a metal frame that would go on top of this to keep the leather held down and screws were driven in. I think that's missing. There's certainly threaded holes there, but there's nothing there. That's a shame, because that would have helped hold things down. Probably a little bit tricky to find one. Or, well, if I had the tools and the equipment, I could fabricate one from a piece of metal, but I don't. So I'll just do the best I can. This is actually coming off really easily. So yeah, I'm gonna. And this isn't good. This is in really good condition. So I'm just gonna keep this here, and I'll glue the fabric onto it. And what type of glue? Well, I suppose I'll just use something like Eileen's tacky glue. If it was cloth to metal, I'm not quite so sure, but this material I think will be much easier to glue to. And what type of fabric? That I'm not so sure on. I'm thinking something synthetic that'll hold up better, like polyester versus cotton, which would not only possibly deteriorate over time more, but I think depending on like the humidity, might stretch or shrink, whereas synthetic will be more stable. I went looking around through my old speakers and came up with this guy, which is an RCA, which appears to be the same diameter. Also is in good condition. I could probably just use this speaker in lieu of the original Stromberg, but I also think that quite possibly the missing metal hoop might just be that this RCA would fit. Oh, so close. The holes don't line up. It's the right diameter, but the mounting holes don't. Might be that enough of them do that I could probably use it, like maybe. Oh, those two on the side are so close, but I don't think they're quite right. But let's see, if I would just use the outer there, and the outer there might line up. And, well, of course I could drill new holes through it too. Anyways. So close, so close. But at least while I'm working on the radio, I have an option for a test speaker to use when I try powering it up. I ran over to the hardware store hoping to find a machine screw 6.5 inches or longer, but alas, they didn't have any. But what they did have was threaded rod, so I picked up a foot-long piece of rod threaded for 832 pitch, which is a nice diameter, a little bit beefier than the old one. And I also picked up some nylon washers to put between these resistors. Now the conductive lug does not come right up to the end. These are meant to be mounted on a chassis. And I'm pretty sure there's enough insulating material that you don't have to use an insulating washer. But when you butt them up next to each other like this, you don't really want to have ceramic against ceramic that could chip and break. So a nylon washer, not a bad idea. So I got one at the end and in between each resistor and one at the other end. And I need to put on this mounting plate. So all that together, and that sandwich there, gives me an idea of how long it needs to be. Now what do I do at this end? Well, I could just put a nut. But that will be visible from outside the end through the chassis there, so I could use one of these guys too, an end cap nut or whatever the heck they call these things. It's a kind of a decorative cap that's threaded on the inside, so put that on there. I need to cut it off to length, and for that I could use something like a hacksaw, but I also have one of these guys, which is a wire stripper multi-tool, also crimping tool, and it has a bolt cutter. So you thread the rod through the hole of the appropriate size, and you squeeze down hard and it snaps it off fairly cleanly. Here are the 8 new capacitors wired in. All have one lead connected together, and that is common ground. I'll run a wire from that over to the side of the can just like the original had, and then when this gets attached to the chassis, the whole can becomes grounded. And the other side go to the 6 lugs and 2 wires just like the original. Unlike the original, however, I turned things around a little bit. So this lug had been in the upper left. That's a major tie point. A lot of wires connect to it. So I want something really solid to be there, so I just simply turn things around. So now this will be in the upper left. And for the one that was clipped off, I went with a viewer suggestion to use a loop of copper wire there. So that will work out well. So I need to hook up that ground wire, tack that in, and then fit this box down in like so. And then I'm going to flood this with black hot glue to seal everything in. Here it is after being sealed with black hot glue. Now all that remains is to remount it and figure out how to hook all those wires back up. I installed the resistors and then the capacitor block, and bit by bit I'm figuring out which wires go where. So I started in the bottom left. Actually no, first I started with the two direct wires that come out of it. One goes right over here and the other one goes right over here. Those are pretty easy to figure out. Especially because the old wires were still there, so I could simply follow them around. And there's still some trace of color and some trace of striping on the old wires. So I could kind of tell that these two are very similar, and indeed when I trace them out, they go to the bottom left lug. Also handy is that some of the original resistors are here, and I know it's 20K resistor. I can find that on the schematic. It's this guy, and I can see that it goes to this tube, and this tube. So I wanted to double check that, and I went around to each of those tubes, and indeed we have a connection going to that tube. So I know which point that is, and the new 22Ks are right here, and I know that this side is one that had the clipped off lug, which is all these guys, so this must go on the other side. You can also kind of tell just from the wires and how long they are and the way they're curving around. Yeah, this probably went over here originally. So we got this one goes to here, these wires go here. I got that lug identified. So as you start connecting them up, there's fewer and fewer left to connect. This guy down here and this guy down here, both fairly short and coming around on this side. So I'm guessing probably one goes on this lug and one goes on this lug, which leaves this guy, which I'm pretty sure goes over here. So once that's out of the way, that takes care of a lot of stuff. I mean, that is the bulk of the paper caps. This one I don't think is necessary. I think that was a later hack. And this one and these dog bones, remember, was to replace this audio transformer, which is no longer here. And I'm going to try using the same trick. I'll just use new resistors and a newer cap to bypass that stuff. Or replace this stuff, I should say, bypass the original interstage transformer. I finished wiring the rebuilt cap back in, and I think I got it all correct. Now, as for this, this is the old bypass circuit for what used to be an interstage transformer up here. Well, I'd mentioned in an earlier installment that one technique to deal with that is, well, what they did back then, which is to use a capacitor and one or two resistors. I found an article online detailing the technique. Here's the address. And it says that you can usually the transformer coupling can usually be replaced by capacitor resistor coupling, often without any loss of performance. He suggests using a 0.1 microfarad at 400 volts, which is exactly what they used. And suggests using a 22K at 1 watt to bypass the primary and out the grid is open, a 100K half watch for that. And finally, says the frequency response will probably be better than the original circuit, which again makes me wonder why they didn't use them back in the day. Sure, capacitor technology was kind of in its infancy. I don't even know if you'd get discrete caps like this, although I think that might be one. But otherwise, all the caps in here are in these metal boxes, with the box being ground. So when using a coupling cap, that box can't be grounded. So maybe it would have been a little tricky, but I still find it hard to believe that a resistor or two and a capacitor wouldn't be far less expensive and easier to do than using a transformer, which I imagine looks something like that. So iron laminations and a bunch of copper wrapped around. Well, I then proceeded to trace out what is actually in here. And here's what I came up with. Somewhat simplified. There are a few other components hanging off the plate of the 37, for example, but this is the critical stuff. So 37 driving a 42, and here's that transformer. So the stuff written in darker ink, that's the original circuitry. The stuff in pencil, that's what was added. So there's that cap that was added between the plate of the 37 and the grid of the 42. And there's resistors we see floating around. One of them is 100K to replace the missing primary. And on the other side, there was already a 100K across the secondary, and then a 500K going to B minus. So a voltage divider to provide some bias here. And what they did is they took two 100Ks in series and put them in parallel with this 100K. That's what this is about. And there's the existing 100K. So that would have the effect of of decreasing this resistance, so there'd be more of a negative voltage on that grid. But what I'm especially curious about is 100K here. There's already a 4K going to B+. That seems like too high of a value. He suggested using 10K, or rather 22K in that online article. So I'm going to need to do some experimentation on that to get this working optimally. So I'm going to clean this up and I'll put in some new components. This is especially ugly up here. I believe this was originally attached to this at some point, and then I need to rebuild that electrolytic block up there, this guy. So, a bit of work left to do. Got a few resistors to replace over here, a few buried down in here. Restuff that cap, replace these, and rebuild that capacitor block. And then wire in my replacement transformers as well. Driver transformer we used to go in the box up here, and the output transformer will mount over here.